Hi, so in this video, we're going to work through 4 past exam style questions on density. I encourage you to give each question a go before you watch my work solution. So if you want to begin with this question, you can pause the video and come back when you're ready. Okay, so I'll come back if you're ready to go. So we have two paints, paint X and paint Y. Both the densities are given. We're told 140 grams of paint X is mixed with 128 grams of paint Y to create paint Z. We need to find the density of paint Z. So the density of paint Z will be its mass divided by its volume. We have the total mass of 140 grams plus the 128 grams of paint Y. So its total mass is 268 grams. So now we need to divide this by its total volume. So if we work out the volume of paint X and the volume of paint Y, and then if we add them together, we'll get the volume of paint Z. So for paint X, we know it has a density of 0.7 grams per centimeter cubed, and we're using a mass of 140 grams. And we know the density will be the mass divided by volume. So if we substitute these values into our equation, we'll get 0.7 is 140 divided by V. So if we move the V to the left-hand side, and then divide both sides by the 0.7, we'll get a volume of 200 centimeters cubed. And now we need to do the same for paint Y. We know its density is 1.6 grams per centimeter cubed, and we're using a mass of 128 grams. So using the same density equation, we'll have 1.6 will equal the mass over the volume. So the volume will be 128 divided by 1.6, which works out as 80 centimeters cubed. Now we can work out the total volume of paint Z by adding these two together, and we'll get 268 grams divided by 280 centimeters cubed. And when you work this out, we have 0.96 grams per centimeter cubed. So how did you get on with that? Let's try another question. So now do you want to read through this question? And we need to work out the density of a custom alloy. And this is made by combining platinum with silver. You can pause the video and come back when you're ready. So we need to find the density of a custom alloy. And this will be its mass divided by its volume. And we're given the total mass in the question as 200 grams. So again, all we need to work out is the total volume. So we need to work out the volume for platinum and the volume for silver. We know platinum has a density of 11.34 and a mass of 74 grams. So 11.34 density will equal the mass divided by the volume. So the volume will be 74 divided by the 11.34, the mass divided by the density. And this works out to be 6.53 centimeters cubed. So this is the volume of a platinum. And for silver, we're told that the density is 7.31 grams per centimeter cubed. And we know the mass is 126 grams. So 7.31, the density will be the mass over the volume. So the volume will be 126 over 7.31, which works out as 17.24 centimeters cubed. So again, we can add these two volumes together, and that'll give us the volume of an alloy. So the volume of an alloy will be 6.53 plus the 17.24, which is 23.77. So the density of the alloy, and this is in centimeters cubed for volume. So the density is going to be 8.4 grams per centimeter cubed. Let's try another question. So now do you want to give this question a go? We need to find the density of a smoothie correct at 2 decimal places. Do you want to pause the video and come back when you're ready? Okay, so we're told that carrot juice, honey, and sparkling water combine to make a smoothie. We've got the density of the carrot juice. Its volume is 25 centimeter cubed. We've got the density of the honey, and its volume is 15 centimeter cubed. For the sparkling water, its density is 0.99, and its volume is 280. So to work out the density of a smoothie, we need the total mass divided by the total volume. And we're told here that the total volume is 320 centimeters cubed. And we can work out the mass of these 3 separate ingredients. So if density equals mass over volume, then the mass will be the density times volume. So for carrot juice, it'll be the density 1.05 times the volume of 25, which works out as 26.25 grams. And then for the honey, the mass will be the density multiplied by the volume, which gives us 21 grams. And for the sparkling water, we'll have the density multiplied by the volume of 280, which gives us 277.2 grams. And we know the total mass is in grams. So we'll have 324.45 over 320. And this is grams per centimeter cubed. So when you work this out, we get 1.0139 grams per centimeter cubed. Okay? Did you get that? Let's try one more question. So this is a slightly different question. We're told that Chloe is trying to find the density of a ceramic tile shaped like a rectangular prism. And we have these lengths given correct to the nearest millimeter. And we're told that she measures a mass in grams to the nearest 5 grams. Using bounds, we need to calculate the density to 2 decimal places. So because we're using bounds, we need to find the maximum density. This will be the upper bound of a mass divided by the lower bound of a volume. We also need to work out the minimum density, which will be the lower bound of a mass divided by the upper bound of a volume. So to work out these upper and lower bounds, we need to find the limits of accuracy from these measurements. So do you want to try and finish this off yourself? Try and work out the maximum density, the minimum density, and then look at how each of these can be rounded to 2 decimal places. You can pause the video and come back when you're ready. Okay, so welcome back if you had a go. So if the length is 13.2 centimeters to the nearest millimeter, then the lower bound will be 13.15 and the upper bound 13.25. And if the width is 16.0 centimeters, the lower bound will be 15.95 and the upper bound 16.05. And for the height, the lower bound will be 21.65 and the upper bound 21.75. So to work out the upper bound of a volume, we'll multiply these 3 together. And we'll get 4,627.3 centimeters cubed. To work out the lower bound, we'll multiply the 3 lowest values possible together. I'll just move this up. And we'll get the lower bound of a volume to be 4,540 0.20 centimeters cubed. And we also need to work out the limits of accuracy for a mass. To work out the upper and lower bound, we know it's being measured to 1970 to the nearest 5, so it can't be 1975 or 1965. So this will be the lower bound, and this will be the upper bound. So now we have our bounds for the volume and mass, we can substitute them back into the densities. So the maximum density will be the upper bound of a mass, which is this one, divided by the lower bound of a volume, which is this one. And this gives us 0.4335 grams per centimeter cubed. And then for the minimum density, we want the lower bound of a mass, which is this one, divided by the upper bound of a volume, which is given here. When we work this out, we get 0.42714 grams per centimeter cubed. So if we go back to the question, we want to calculate the density to 2 decimal places. Well, you can see that to the 2 decimal places, this 3 doesn't round up this 3, so it becomes 0.43 grams per centimeter cubed. And in the minimum, the 7 does round up a 2. So again, we get 0.43 grams per centimeter cubed. So this would be the level of accuracy using bounds. Okay?